key concepts related to the movement of the Earth and Moon can be better understood with the help of this model. Let me walk you through the process of assembly and configuration first. This powder-coated metal frame holds all parts together. We will call this main gear. Insert this small gear in the axle next to the main gear. And another similar gear in the axle as shown. The Earth and Moon unit can be placed on the large thick axle near the handle. This is a slider for the Moon. It rotates freely by hand. Now let us add remaining gear. Make sure that you have some free space to insert this gear. This gear is also called compound gear. It has a large gear at the top and smaller one at the bottom. Large gear connects with the Earth and Moon unit. Smaller one connects with G1 and G2. Let us place the blue Earth here. This is a Moon attachment. Wheel provided should rest on the inclined platform. Our unit is ready. Let us place it on a dial. Let us orient the dial properly. There are 4 icons, 2 for equinoxes and 2 for solstices. Ensure that dial is placed such that 22nd September date is nearer to you and 22nd March away from you. This will help to configure the orientation of Earth's axis properly. Hold the assembled unit with both hands as shown and slowly insert it in the square pipe provided. This is the sun holder. We'll place it in the square pipe. Let us attach zodiac pointer as well. Now let us orient the Earth's axis properly. With the help of a handle, move the Earth near the date 15th of June. Now move the base gear of the Earth unit by hand until axis of Earth is pointing towards the Sun. It should align with the base gear of Earth unit and compound gear. Now the axis of the Earth is oriented properly. On 22nd June, we have the longest day of the year in the northern hemisphere. This setup needs to be done whenever you assemble the model. Let us explore key features which can be explained with the help of a model. Rotation of Earth, revolution of Earth and Moon happens in anti-clockwise direction. On a new moon day, the moon is between the sun and the earth, while on full moon day, the earth is between the sun and the moon. These are also the positions when solar eclipse and lunar eclipse can happen. orbit of the moon is tilted with respect to the plane in which Earth revolves around the sun. This is the reason the moon is sometimes above or below this plane. But at some points during 1 year, it comes in line with the Earth and moon. This is the time when eclipse occurs. Just like we adjusted the position of Earth's axis during initial setup, we can also adjust the position of the moon. Lift this gear slightly and you can freely rotate the moon wherever you want to position it. We can remove the Earth from this tilted axis and place it in the center like this. With this setup, now one area of the Earth is tilted towards the Sun. We can also remove the moon and put it back like this. With the help of a straw, I can position it like this. Wheel is not touching the inclined orbit now. Now, the moon is revolving around the Earth at constant height. Likelihood of eclipses occurring on all new as well as full moons. Let us remove it and reset the moon. As you can see, meshing of gears is purposely kept loose. This may result in some movement of the unit when you take your hand away from the handle. This is normal. Ensure that you don't leave your hand from the handle when measuring some duration on the dial. Now that you are familiar with the model, here are some assignments for you to try out. Once you are done with the model interaction, it's always safe to keep all the components back in the box. I hope you can interact with students better with the help of this model. If you have any queries, please post it in the comment section, or you can always email me. Thank you.